Now the example. The example, I told you we are not doing hyper-eutectoid. We are again doing hypo-eutectoid. Hypo-eutectoid, but a different kind. So read it carefully. A hypo-eutectoid plain carbon steel was slow cooled from the austenitic region, right? At the region where austenite is there, to room temperature. Once it is cooled to room temperature, it contains 9.1 weight% eutectoid ferrite. So the mass fraction of the eutectoid ferrite at room temperature is given. Assuming no change in structure on cooling from just below the eutectoid temperature to room temperature, what is the carbon content of the steel? What is the carbon content of the steel? So what is the question? Do you understand? There is a hypo-eutectoid steel, but the composition of the steel is not given. It is unknown. It is unknown. It is hypo-eutectoid. It is less than 0.8% carbon. But the composition is unknown. So let us say the composition is X. So we will, in the hypo-eutectoid region, you draw a vertical line and the composition is X. They say now that you start from the austenite region, keep on cooling it until you hit the eutectoid temperature. Then all the reactions will happen, right? All the reactions will happen. After that, when you cool to room temperature, the structure will remain the same. In this final structure, there is 9.1 weight% eutectoid ferrite. This is the given. And the unknown is, what is the composition? What is the carbon content of the original steel? Okay. So I'm showing you the eutectoid, hypoeutectoid region, right? This is the eutectoid thing. This is hypoeutectoid. This is hypereutectoid. But in the problem, what is given? A hypoeutectoid steel. So any steel here, you can draw the line here or here or here, wherever you like it. So draw a vertical line in the hypoeutectoid region and call it X. Call it X. Now when you cool it, there is all gamma. Then you will have alpha plus gamma. So some alpha will form above this line. And once you hit this line, the remaining gamma will change into alpha plus 7 type. So remember, there will be two types. I mean, once you hit this temperature or any temperature below, the structure is the same. There is some alpha which is pro-eutectoid alpha, pro-eutectoid ferrite. And then there is some alpha which is the eutectoid alpha, eutectoid ferrite. So just below it, you have total alpha, and total alpha is equal to pro-eutectoid alpha plus eutectoid alpha. Therefore, I am reminding you of the equation. Eutectoid ferrite is total ferrite minus pro-eutectoid ferrite. So this is your equation. That is where you will solve the problem. Now in the question, eutectoid ferrite is already given, so don't worry about it. For total ferrite, what should we do? Where is total ferrite? It is just below the line, isn't it? This is the line for eutectoid temperature, 723 Celsius. Just above it is the pro-eutectoid region. So draw a tie line here just above this for the pro-eutectoid ferrite, and draw a tie line just below this from here all the way to there for the total ferrite. Okay, so for the pro-eutectoid ferrite, your tie line is from here till here, right? On the left is alpha 0.02, in the middle is X, and on the right is gamma 0.08. So this is for pro-eutectoid. For the total ferrite, your line is just below. So on your left is alpha 0.02, in the middle is X, and on the right is 6.6% cementite, 6.67% cementite. So, right, for the total ferrite, you see, ferrite means on the left side. Therefore, on the tie line, it will be on the right, right? So this is your total line, 6.67 minus X upon 6.67 minus 0.02. This is the total ferrite. So this is your right here. And for the pro-eutectoid, again for ferrite, the right hand side of the tie line. So 0.8 minus X upon 0.8 minus 0.02. You put it here. Once you put all the values here, there is an X which is an unknown. This is given in the question. What was the amount of eutectoid ferrite? 9.1%. And then you just solve this equation, right? So on the next page, that is what we are doing. I am telling you that solving means eutectoid ferrite is total minus pro-eutectoid. This is the diagram for total ferrite. You write total ferrite, you write the Lever equation. For pro-eutectoid, you write the Lever equation, right? And then just simplify it, right? These are just numbers. So add, subtract, just the numbers are there. And once you divide and this and that, then these numbers are there. Take this x to the left hand side, take this x to the left hand side, because x is what you want to find out. The remaining numbers, actual numbers, this 0.091 and the other numbers are here. And then in the end, if you solve for x, x is 0.101% carbon. So this percentage of carbon is 0.1% carbon roughly. So this is your answer, right? So this is another example that rather than giving you the composition of the steel, we say that there is unknown composition, but this is hypoeutectoid steel. So in the hypoeutectoid region, you draw a line with X. I could have given you the same problem with a hypereutectoid steel. So you will draw an X line anywhere here, anywhere here. So you will have gamma and then gamma plus cementite and then alpha plus cementite. So you will solve the same way. So I can give you an X unknown composition for any alloy diagram. We can do it for lead tin diagram. We can do it for iron carbide diagram. So now you have learned that if the initial composition is unknown, but one of the final compositions is shown 9.1% eutectoid ferrite, right? Then we can again solve the problems. Okay. So with this, we come to the end of this chapter. This chapter is a very big chapter on engineering alloys. So in the book, there are many other alloys, magnesium alloys, aluminum alloys, this, that, many other complicated alloys. But our main concern was not to go to learn all the alloys. If in your field you end up in a metal company, then very quickly you will learn what metals they make. For us, the main idea was that if they are alloys of metals, then can we solve the different problems? So chapter 8 was phase diagrams. Phase diagrams are for alloys. And until now, we have done only one type, binary alloys, right? Every time there are two components. But we did many types, lead tin diagram, silver palladium diagram, copper nickel diagram, now iron carbide diagram. So we have done many of the famous alloys in the world. Initially, binary isomorphous alloys when there is only one solid phase. Then binary eutectic alloys where there is a eutectic point and there are two solid phases in the end. Then a binary eutectoid type of alloy where again there are two types of phases in the end, and there is pro-eutectoid and eutectoid in terms of temperature, whether you are above the line or below the line of temperature. And especially for the steel diagram, 0.8% is the eutectoid point. So any steel less than that is hypoeutectoid, and any steel more than 0.8% carbon is hypereutectoid steel. So for us, we have finished the chapters. Just a reminder that you see I am using the chapter numbers of Smith and Hashimi. In Callister, the book that you have, the chapter numbers will be different, but just go to the Callister book and see where phase diagrams are there and where the phase diagram of iron carbide is there. So otherwise you have binary isomorphous alloys, binary eutectic alloys, binary eutectoid alloys. So the same thing is there, but as long as you understand all the material and the examples in the lectures, then you are already very good. And again, very shortly we will send you some homework also so that you have some additional practice. Now this is where we end now. So for the whole course, chapter 1 was introduction about the whole course. Chapter 6 was mechanical properties of metallic materials. We went back to chapter 3, which was crystal structures, which are usually metals. After doing these three, then we did chapter 8 and chapter 9, which are phase diagrams of engineering alloys. Now we go back to chapter 4. Chapter 3 is crystal structures. Chapter 4 will be defects at the crystal level. So we go back to basics of material science in chapter 4. So the next lecture will be chapter 4. We will start chapter 4 today again, right? Because this was very short. So we will do a little bit of lecturing of chapter 4. So please look for lecture 1 of chapter 4 now, and take a small break and then start that. This will be a smaller lecture compared to normal, so that the lecture 2 on chapter 9, which we just finished, and lecture 1 of chapter 4 that you will do together are roughly one class, right? So thanks a lot. We'll see you again shortly after the break. Ma salama.